factors. Biogenic is very small, which you would expect in an urban industrial area. Fuel evaporation is about 14%, exhaust is about 15%, so vehicles are about 30%. The aromatics, ethylene, propene, that's clearly some industrial component, but what specifically, I don't know. The LPG isn't LPG that is retail. I mean, it's somewhere in the production side of things, because LPG isn't used in the U.S. and certainly not in Texas to anywhere near that extent. So this is really an industrial piece that looks like LPG. That's what's volatilizing, and it's probably an industrial issue. This is a petroleum refining component that has a lot of things that look like natural gas, but it has some other stuff which includes that process of call it a natural gas crude oil factory. Of these, about 2/3 of the emissions you know quite a bit about, but not very useful stuff yet. What source did it come from? Or what sources? And the problem with PMF approach is you can get things grouped so that you have reasonable confidence they're coming from the same kinds of places in these kinds of proportions, but where do the aromatics come from? Or ethylene? And so that requires information about the specific sources. Most receptor modeling starts at the other end with information about the specific sources and seeing how it affects the ambient concentrations. And getting source-specific information is more difficult, but you need some kind of indication of source-specific information in order to help you interpret the kind of data you get. If nothing else, running around with the canister grab sample near various sources under low wind speed conditions when you're down into the facility to give you some clue as to what is probably fairly low. But you need some idea of what's coming from the different sources. Okay. Because you have hourly data, you have hourly contributions of these various factors to the total VOCs, and so you've got hourly profiles of the different sources. The biogenic source, most of the biogenic emissions are during the day. That's good. That gives you a clue that maybe you've identified that properly. The other issue that you see often with diurnal profiles is that they look like a typical ambient diurnal profile. Well, when you add them all together, they have to. So a lot of these components are going to look like that. There's going to be a morning peak and an evening peak, and it's going to be relatively low in the middle of the day, which doesn't tell you that the emissions are high only in the morning and the evening and low in the middle of the day. It tells you that mixing height was low in the morning and evening and high in the middle of the day, and it's getting diluted more. So you're not sorting out just the source component, but the source after it's been stuck in the atmosphere. So there's dilution in there that complicates your life a little bit as well. So the diurnal profile doesn't give you as much information as you would like until you go back and try and figure out how to get the dilution piece out of your wind speed effects and mixing height effects and so on. But clearly in dealing with something like the biogenic, it is useful. And for some of the others, it may be more or less useful. Certainly, molecules that don't follow an ambient kind of profile that's telling you something about this aromatic profile, for example, where it's high through the night and early part of the day, it drops in the middle of the day. Well, the drop in the middle of the day is probably just better mixing, diluting it. But it tells you that this source is probably fairly constant day and night. It doesn't have much diurnal character. Something like the vehicle exhaust factor, I mean, that is a common morning, evening peak and relatively low at night by comparison. Okay, so the source apportionment that we looked at was for the urban sites. Since there are continuous GCs, all of these are in various industrial locations. You can see get a better idea of what's coming from things in the vicinity of each of these other GCs. Since there are enough of them scattered around, well, there aren't enough it's a huge area, a lot of industry, but there are more of them, you can get some differences, see some differences in the profiles. These are apportioned similarly. Sometimes factors don't fully separate. See here, you've got an E and F combined, and this one you've got E and F combined. So ethylene and propylene were picked out together, and they didn't separate as cleanly as they would in some other profiles. But H is the crude oil, natural gas. This factor is there everywhere. In some places it can be close to half of the VOCs. Other places it's maybe 30-ish% of the VOCs. And so if this is a more refining, petroleum refining kind of area than some of the other areas, that helps you identify some of the sources, looking at what's near the LOVC. See, it still isn't as much detail as you'd like, as you will be able to get if you really had source-specific emissions information. The problem with that is big facilities have a number of different sources around the plant site of different things because it's different parts of the process. And there can be several different factors coming from different parts of the same facility. This one?
The one you just talked about. Yeah.
Sorry.
At the location, you differentiate between benzene from aromatic group, right? Because only in Merck that you have identified benzene.
Benzene is going to be in several of the factors. I mean, it'll be in the fuel evaporation, it'll be in the vehicle exhaust, it'll be in the aromatic factor at different fractions. And that is what you see here. Benzene is 34. 34 is right here. So this is benzene. There's not much in the biogenic. This is benzene in the exhaust. There's not a lot of it in the aromatics, which is often the case. There'll be a little bit of it over here in the natural gas and crude oil factor.
Because at in those locations, you have identified the density is about 12%. So this 12% is subtract from like field evacuation and gas leak, right?
What did I say was 12%?
12%. The last section. At the site, at this location. So this is that forming.
Okay. Yeah, I'm sorry, that is a factor where benzene separated from all the other sources. And so it's just largely benzene, although there will be other things, whatever that factor is, and I don't have the diagram. But that is just a chunk of benzene that behaved differently than the other sources and didn't move with, didn't change the concentration the same way that other sources did. So that's a separate factor that it pulls out in this model. This one still has 2, 3, 4, 5. This only has 6 factors that it identifies.
But there is no aromatic in this location, so mostly aromatic could be.
I mean, the problem is every time you run the model on a set of data, it's going to sort of, however, the concentrations vary. And it may be because there are more different sources that are affecting this one side than some of the others, that you don't have an aromatic factor. And the aromatic factor, as it came out, didn't have much benzene in it. It had more other aromatics. You won't get factors that have the same kinds of contribution at each of the sites, which is telling you that you haven't gotten enough of the identification. I haven't got them separated well enough. But there are way too many sources to be able to do that very well. I mean, it's one of the limitations, one of the many limitations of the approach. I'm sorry, I hadn't realized there was actually a separate benzene factor in that. Anything else? We'll shift gears to Denver. This was a monitoring study that was really interested in looking at air toxics, and the part that I will talk about are looking at C6 VOCs, and so the one we're really most interested in is benzene. This plot shows a map of the urban part of Denver. Each of these blue dots is a permitted source of benzene. The shades of purple are model, and a few greens and reds are modeled annual average benzene for this area based on the sources and meteorology and so on. The real purpose is to identify 4 monitoring sites that we were using in this study. Both the data that I'm going to talk about, the online GC operated